Now let's talk about conservation of momentum and proof. Coming to the definition, the law of conservation of momentum states that in the absence of external unbalanced force, the total momentum of a system of objects remains unchanged. What is meant by momentum is the quantity of a moving body measured as a product of its mass and velocity. So, in the absence of external unbalanced force, the total momentum of a system of objects remains unchanged or conserved. Conserved is nothing but to maintain a quantity such as energy at a constant overall total system. By collision. A collision is an event in which two or more bodies exert force on each other for a relatively short time. So, the law of conservation of momentum states that in the absence of external unbalanced force, the total momentum of a system of objects remains unchanged or conserved by collision. Let us consider small example: spinning top. Once you rotate, it keeps spinning. Consider this point. This will have some momentum and this will move with some specific velocity, and this moves in this direction. When you consider this point, it will have some magnitude and this will move in opposite direction. Similarly, for every point, the momentum will get cancelled by another such point on another side. So, the net momentum is equal to 0, is conserved. Even though the top is spinning from one position to another, the entire momentum of the system is conserved. Now we discuss about proof for the conservation of momentum. Consider the first diagram. The two objects A and B of masses m1 and m2 are traveling in the same direction along a straight line at different velocities u1 and u2 respectively. There are no other external unbalanced force acting on them. In the second diagram, u1 greater than u2 and the two balls collide with each other, as shown in the figure. During collision, which lasts for time t, the ball A exerts a force F1 on ball B and the ball B exerts a force F2 on ball A. After collision, the third diagram, V1 and V2 be the velocities of two balls A and B respectively in the same direction as before collision. According to Newton's second law of motion, the force acting on B, that is action F1, is equal to mass of B into acceleration on B. That is F1 is equal to m2 into v2 minus u2 divided by t is the first equation. The force acting on A, that is reaction F2, is equal to mass of A into acceleration on A. That is F2 is equal to m1 into v1 minus u1 divided by t. According to Newton's third law of motion, for every action there is equal and opposite reaction. So, F1 is equal to minus F2. From equation 1 and 2, m2 into v2 minus u2 divided by t is equal to minus m1 into v1 minus u1 divided by t. T get cancel each other, so m2 into v2 minus u2 is equal to minus m1 into v1 minus u1. So multiplying m2 v2 minus m2 u2 is equal to minus m1 v1 plus m1 u1. So m1 v1 plus m2 v2 is equal to m1 u1 plus m1 u2. So the total momentum before collision is equal to the total momentum after collision. The total momentum of two objects remain unchanged due to collision in the absence of external force.